Welcome to Honors Geometry, Lesson 3.1, Lines, Transversals, and Resulting Angles. In this chapter, we're going to talk about parallel lines and perpendicular lines a lot. Before we do that, I want to talk about intersecting lines and the results of those intersecting lines and how they make different angles. So let's go ahead and move forward if we dare. Alright. Right now, with the picture I have there, I've got T intersecting both M and N, not at the same point. Let's go ahead and throw this definition out here. A transversal is a line that intersects two or more lines at different points. So line T there is a transversal because it's hitting M and N at different points. Now some cool things happen, but we'll go ahead and move on. Corresponding angles. Thus from now on you can abbreviate them as I have them here, core angles. Corresponding angles are on the same side of the transversal and in the same relative location with the other lines. That is to say, they're both above, both below, both to the right, both to the left, depending on how the transversal is drawn and how the lines are. So let's go ahead and look at an example of corresponding angles. Right here. The transversal is oblique here, this line here, and then these two lines appear to be parallel, but we're not sure about it right now. Okay, so they are both on the same side and they're both above the other two lines. They're in the same relative location. They're both to the right of the transversal and they're both above the other two lines. And I'll go ahead and show you the other pairs of corresponding angles. To the right of the transversal, below the lines. To the left of the transversal, below the lines. To the left of the transversal, above the lines. You want to see those again? I'll see if I can do this quickly. That was kind of fun. Let's do it again, back the other way. Those are corresponding angles. Alternate interior angles. Alternate interior angles, thusly abbreviated so you don't have to write it out, alt-int angles, are on opposite sides of the transversal inside the other two lines. Let's go ahead and look at an example of alternate interior angles. There you go. They are on opposite sides of this oblique transversal. Oblique just means it doesn't intersect at a right angle. So this transversal is oblique. They're on opposite sides, but they're still inside the two lines. Those are called alternate interior. Alternate because they're on opposite sides of the parallel. Interior because they're inside the bounds of these two lines here. That's why they're called alternate interior. The other pair of alternate interior angles are right there. Kind of reminds me of school bus flashers going on here. Alternate interior angles. I'm having fun with this. I don't know if you are, but I am. Those are alternate interiors. So let's move on. Alternate exteriors, from now on abbreviated if you so please. Alt-X angles are on opposite sides of the transversal outside the other two lines. And those would look something like this. And there you go. Alternate exterior angles. They're on opposite sides of the transversal. This one's on the right side, this one's on the left side. They are outside the lines. Look, they're not between the lines here, but they're outside of the lines. That's why they're called exterior. Alternate exterior angles. And once again, these kind of look like bus flashers. Don't they? Those will be alternate exterior angles. We've got one more angle pair to find out. Consecutive interior angles. Constant angles, if you want to so abbreviate them, are on the same side of the transversal and inside the other lines. That would be consecutive interior. Some books call them same side interior, obviously because they're on the same side. Let's go have a gander at those. Alright, they're both on the right side, left side of the transversal, and they're inside the lines. Those two angles are consecutive interior angles. Those are the two angles on the right that are inside the lines. Those would be consecutive interior angles as well. Those two pairs of angles are consecutive interiors. Now, here's the place where I would have people come up on the board in the classroom and just go ahead and identify all the different angles that are going on here. So instead, what I'm going to ask you to do is draw this picture. Of course, you're going to have to pause it because I've been moving way too fast for you to even write all this stuff down, and that's okay. Alright, this is what we're going to do. First, I'm going to ask you to write down all pairs of corresponding angles. And you should come up with 4 angle pairs. So go ahead and pause, write down those 4 pairs, and come back and check with me. Alright, pause. And those are the 4 pairs of corresponding angles. Angle 1 and 5, 2 and 6, 3 and 7, and 4 and 8, the corresponding angles. Alright, the next 2 pairs I'd like you to find are the alternate interior angles. And this time, instead of pausing, well, you're going to pause, but I'm not going to. I'm just going to keep on writing. You go ahead and try to guess. Good. Angle 3 and angle 6. Those are alternate interiors. They're on opposite sides of the transversal, but they're inside. Alternate interior. The other pair of alternate interiors, angle 4 and angle 5. The alternate exterior angles. Okay, they're on opposite sides and they're outside the lines. Angle 1 and angle 8. Angle 2 and angle 7. And I ran out of room over there, so I'll do the consecutive interior angles. Should have 2 pairs of those. Angle 3 and angle 5. And also angle 4 and angle 6. And those are all the angle pairs for a pair of lines that have been cut by a transversal. Actually, there are more, but we'll not get to them. So this will conclude lesson 3.1, lines, angles, and transversals. Thank you. Have a good evening.